Good morning. So, before we get started, I have actually the rare chance to see the audience. So, who of you is using one of the Elastic products like Elasticsearch, Logstash, Kibana, or Beats already? Okay, so we have about 30%. That's good. Machi already mentioned it. This is where I'm from. Usually, people don't recognize this until I show this picture. Really visit Munich when there's not Oktoberfest and the other 345 days a year, and it's still an awesome city. I work on Elasticsearch. I'm a developer, and it's commercial extensions. If there's something with networking or netty, it's probably a bug I introduced in Elasticsearch. I'm also highly interested in basketball and Linux, obviously, and just a quick introduction into Elastic, the company. We are like 350 people nowadays. The company was founded in 2012. Obviously, there are 4 open source products, which I'm going to cover today, which is Elasticsearch, Beats, Kibana, and Logstash. And obviously, there's cloud-hosted Elasticsearch and XPack, its commercial extensions. There's Conway's Law, which decides that organizations create products which resemble the organization structure. And because Elasticsearch is a distributed system, the company itself is completely distributed as well. These are the locations of all of my engineering colleagues and support. So you can see we are truly distributed with a strong focus on US and Europe. And yeah, I'm in Munich, and we have a couple of offices in Amsterdam, Mountain View, Phoenix, Sydney, Berlin, and London. So let's talk about logging. Why logging? Usually, you need to answer certain questions coming from very different directions inside of a company. There might be the question, how many users signed up for a newsletter this week? There might be a question, how successful is our advertising campaign? Depending on what successful means. Might be how many people opened the newsletter, how many people signed up for the newsletter. So it's a very different metric. Your VP operations might ask you, when should we schedule maintenance? Is it when the traffic is the most lowest one, or is it when you don't make any money? And that might be a completely different time. And obviously, an all-time high of questions, why is the database slow? And the answer to all of those questions is somewhere carefully hidden in your log files. Maybe database logs, maybe syslogs, maybe application logs. And this brings us to one fundamental problem. Logging is hard. And I'm not talking about what the developer has to do, which is basically just generating a log message and be done, but I'm talking about logging as an infrastructure component. And this is the really hard part. You need to set it up, and you need to keep a lot of things in mind in order to have a good working logging infrastructure. The first thing is you require some expertise. So if there's an exception, you need a Java developer who knows Java and a Java developer who knows the system in order to decipher it. Also, simple questions like, where are the log files on my production system, might be something that not every developer is aware of. You need access rights. If you're a big company with thousands of employees, it's suddenly really, really hard to actually give every developer access to the live systems, which you really don't want to do. And we have the features of unstructured logging. Most of the logging that we do nowadays looks like this. And this is a Java exception. This is a single event. Some is indented. Everything is multi-line, and there's no structure in it. And somewhere inside, there's a problem, but it's really, really hard to find out where. So it's hard to spot the real cause. So people figured we need something better and created semi-structured logging, which basically means you have some part which is structured, like in this example, it's a syslog message where the date and the host name is always at the same position. But after that, everything is kind of freestyle again. So you need some more mechanisms to make sense of the rest of the log files. And even if you're kind of advanced in your logging infrastructure and you have structured logging all over the place, this still means that there's some component which needs to understand the structure. This is a structure. This is an exception which is written in JSON format. But if you don't know the structure, it doesn't help you. So you still need to invest time in your structured logging in order to extract the real content out of it. This is structured logging as well. And this is something that most of you probably know. It's an Apache log file logline. And the structure is well given. It's a well-known format. And I still bet that most of you don't know the 2 dashes at the beginning, what they actually stand for. It's just a format that has been there for 20 years, and no one ever changes it, because most parsers work like that. Timestamps are an interesting topic to keep in mind, because timestamps are very, very different. Just take this. Take the one at the top. This one is from the Apache logline we just saw. And someone decided to invent this awesome format which starts with slashes to split the day and the months, then turns to colons, but adds a space before the time zone and puts everything in brackets. So this looks really arbitrary, but everyone has kind of accepted that this is a valid timestamp. The one on the top left doesn't have a time zone, it doesn't have a year, so we don't know really when this has happened, and that's tricky for any logging application. The one on the bottom left is basically an internal kernel date. The right one is a Unix timestamp, which is great for machines to parse, which is horrible for humans to decipher. And the one at the bottom contains a month, a year, a day, but I don't really know which is which, so it's again really hard to decipher. And this brings us to the point that if you want to have some logging infrastructure, you need to do some enrichment yourself. You need to normalize those timestamps. You need to extract information from a single log line and put it into separate fields. And you may want to do some additional enrichment, like having an IP address and actually looking up to which country or city this belongs. And this is something that your logging solution should be able to do. Also, centralization is a big topic. Again, if your developers don't have access right to all systems, they still need to be able to access the log files. So you have to send your files or your data somewhere to centralize it, and still be able to not introduce a single point of failure here. Which also means we need to ship log files in one way or another from the systems where they are generated to the systems where they are stored. And this means you need to decide how to get the logs from A to B. You need to decide, should you still write files, or can you send them over the network? You have to decide if shipping of your log files over the network is impacting your production data, is impacting your production systems if there's a peak. So this is all things you need to be aware of. Then you have to do analytics on top of the data you store. If you don't analyze, just storing the data won't gain you anything. So you need to define metrics, what is important, what is unimportant. And obviously, you need to visualize all this data that you're collecting. If you're just collecting without visualization, in my opinion, this data doesn't really exist. It's just written somewhere, and that doesn't help you to find errors or do root cause analysis or anything like that. On top of that, alerting obviously is important. If there's some spike going on, you may want to notify someone. If this happens at 3 a.m. at the night, you may want to page someone. So you need some sort of logic to define how your alerts are actually looking like. And you have to cater for outages. If your logging host or logging system is not available, what happens? Are you fine with actually losing data? Or is it okay to buffer this kind of data on the system that is sending it without affecting the service? Can you make sure that an outage of your logging system does not affect your live system? And how long of an outage can you sustain? On top of that, if an outage is happening, you can be pretty sure that shortly after that, a peak is going to happen. This means you have a burst of messages coming in, and you need to be able to handle those. Also, when there's a distributed denial of service attack on your systems, are you able to handle this? Again, will log files impact your live traffic because they send data through the same network? These are all things you have to keep in mind. But on the upside, I think those are all things that many people already thought about. So this is kind of the old school logging, which many people have in place and are up and running with. But logging got harder. Over the last years, with recent advances in technology, logging as infrastructure got more complex because of this. We all know this wonderful term because you can't escape it, basically. But what this means from a logging perspective is that instead of a big service which writes single log messages, you suddenly have a bunch of services that write log messages. And those services call each other, and how do you follow the trail of a single request when you have this kind of infrastructure? That's really hard. You usually start with something like an ID, which is passed through all the requests, so you're able to follow it. Similar when you do exception handling in multi-tiered architectures, but it's just more tough, and it also requires your logging infrastructure to cope with this. Same with handling dependencies. When you have versioned APIs, when can you decommission the oldest one? It's something that's up in the logs, but you need to have the infrastructure for this. Next part, serverless. Serverless is the next big thing, like AWS Lambda or Google and Azure Cloud Functions. So I think serverless is going to be a huge thing where you just take your code, upload it somewhere, and The other part is basically taking care of the whole execution environment. But this means you're running your code somewhere else, which just means that there's probably someone else's computer failing at some time. Also, what happens with your logs? If the code is running somewhere else, it's also generating logs somewhere else, and you need to make sure you get them back into your system in order to debug things. So this is a tricky thing. And obviously, vendor login might be a problem with this, especially in order to get the logs out. The next big development is stuff like Mesos, Kubernetes, Docker, Docker Swarm. So you have those kind of management platforms for whole applications, for VMs, depending on which level you're running it. And this also means you don't know really, as a developer, where your software is running nowadays. You just know it's up and running, maybe 10 instances, maybe 100, and you still need to get all of those logs. So you need to make sure that instead of running those instances, all of them are provisioned to distribute the logs somewhere. And we obviously have short-lived services, which basically means that you have services that are only there for a short time, but instead of just shutting them down, you still need to make sure that before shutting down, you're sending the logs to some central place. And this brings us to the lifecycle of a log. When I'm talking about log as a single event that's about to happen, like a single syslog message or a single log message your application is generating, something needs to happen. We have the creation going on. We need to ship it somewhere. We need to centralize it somewhere, potentially. Then we're going to enrich it. And at that stage, we need to store it. And the moment it's stored, we can basically query it. It's kind of normalized so that even very different logs and very different log formats are easy to query. It's one of the important things of logging. Optimized for query, not optimized for storage, because otherwise you can't ask questions. The next part is to analyze your data and to visualize those. So visualize and alerting are basically the seventh step, depending on how you set up your infrastructure. And at some point, you're going to archive this or delete it, depending on your legal requirements. The important part of this is that the first 7 steps need to be as short as possible, because the moment an event is created, until you can actually see it on your dashboard or get alerted, needs to be as short as possible in order to react to possible outages or problems. So, how do we do this? First, we obviously need a shipper, meaning one component to send data. And in the Elasticsearch, those shippers are called beats. We will cover them a bit more in a second. And it's basically a lightweight process which makes sure that your data gets shipped from one system to another. And this also means you need a receiver. And the receiver is basically something like Logstash, which receives the data and can potentially do some more enrichment on this or remove fields, whatever you need. And on top of that, we have, or instead of that in this example, we have Elasticsearch, which is basically the part during the storage. Of course, you can mix this, having beats, Logstash, and Elasticsearch as sort of a processing pipeline. And the last part is Kibana. The nice part of this kind of architecture is that you have different components for generating data, for enriching data, and for storing. And so scaling out is pretty simple. You probably end up with more beats because you have more than one system to monitor. So this is usually the first component you're supposed to scale. If your processing pipeline gets slow because you're doing some CPU-intensive computations, it's easy to just add more Logstash nodes and to have beats sending the data to one of those. And of course, when we need to have more space to store data, to analyze data, to query data, you can just scale up there as well. So we kind of removed single points of failure in this architecture using the different products of the Elastic Stack, but there's one thing which I'm usually not happy with those diagrams, and this is this arrow. The arrow is one of the most crucial parts of getting data from A to B, and many people are just drawing an arrow and then everything is fine. But it's usually not. It's a crucial link, and the crucial link needs to fulfill a certain set of properties. One of them is that this crucial link potentially needs to be encrypted because you're sending stuff across data center, so you need to use TLS. You may need to use authentication because not everyone should send data back and forth. When you send data over to Logstash, you should be able to X those messages so you know you really sent them off. You may want to tag those messages with some additional information like the host where it was generated or a specific log file which needs a specific tag. And compression makes a lot of sense for log file data because compression usually is pretty high. On top of that, the beat itself doesn't have any dependencies. It's basically just a Go binary, and there are different kinds of beats. So beats is basically just a very specialized tool. Like there's a file beat for reading files, which is basically a smart tail minus F over the network. There's a top beat, which reads out system statistics. So there are different kinds of beats. They are highly specialized. And yeah, that also makes them lightweight. If you have another JVM process on your web server just to send log files, people are usually reluctant. But a Go binary has a pretty small footprint. So now we have this kind of setup. But we have one problem. If this connection fails from beats to Logstash, we might actually lose data. Because either you decide that on the site where the beat is running, you start like caching up requests, which again has a memory impact, or you try to send them directly and the connection fails. And this means that you can't do maintenance on Logstash, you can't do maintenance on Elasticsearch, because suddenly you're going to lose data. And that's not what you want. So in order to decouple the beats writes from the Logstash reads, you can introduce something like a broker in between, which in this example is Kafka or Redis. And this basically means that even if there's a peak, you're just going to write more data into the broker, but Elasticsearch and Logstash will still keep up with the processing. And this also means that one of your systems or both can die or you can do maintenance, and the beats keep writing the log data without being affected by this. And I think this is really, really important in your infrastructure. So that was a kind of architectural overview. And now we quickly dive into visualizations, because I think if you don't have this in place, you don't need monitoring. If you can't see what happens, it's really hard to spot issues. So Kibana is basically a tool to query Elasticsearch and create visualizations out of the query results. And it's basically using aggregations. So you usually see aggregates of the data instead of like single document data, because that's not how you spot flaws. And Kibana allows you to create single visualizations like this one, which shows you the different user agents over time. But it usually makes far more sense to put several visualizations in one place and basically show this somewhere in your office as a dashboard to easily spot issues. Again, there are a couple of different widgets. You just saw the geomap. There are widgets which just show a count, like in the upper right. There are widgets which are basically kind of circle diagrams or cake diagrams. And one of the nice things we actually did with Kibana is to make it pluggable in the recent releases. And Rashid wrote a plugin which is called Timeline, which is a time series composer for Kibana. And it allows you to work easily with time series data. And in this example, if we take a look at the query, we are basically not querying Elasticsearch, but another data source. WBI is the World Bank interface, which contains information of the population of a country over time. And the interesting part here is that you can apply functions to the data being returned. So in this example, we are getting the population data of Mozambique and Malawi. And from both of them, we do a derivative function in order to find out how much this changed. And what we can see in the graph on the top left corner is that the population of one country actually spiked, and the one of the other country actually had a low spike, basically, or decreased sharply. The reason for this is that in one of the countries, there was a war going on, and when the war was over, the people actually moved back. And working with Timeline makes it really simple to apply different kinds of functions on top of this data. And it makes it really simple to see this kind of things. Another interesting plugin basically is Sense, or Console as it's called now, which is basically the missing UI for Elasticsearch. This is going to be standardly incorporated in Kibana 5.0. And it basically allows you to not only have kind of a JSON check going on before executing queries against Elasticsearch, it also has autocompletion. So you don't have to know all the different kinds of queries. You can just press a key and you see the values which you're expected to insert at this point in the query. And it's not only for queries, this autocompletion works for all kinds of requests. So this is really powerful. So I talked a lot about architecture, but if you just have a couple of Apache logs that you really want to visualize in a quick way, setting up something like Redis, Kafka, Logstash, Elasticsearch, and something like that is too complex and too cumbersome. And because we kind of realized this, Elasticsearch 5.0, the next upcoming major release, will have a nice feature called the Ingest Pipeline. And the ingest pipeline basically allows you to configure a set of steps that modify the incoming data before it's being stored. So in this setup, we could use Beats or any other tool to just send data to Elasticsearch, and Elasticsearch is doing some kind of enrichment before the document is stored. And similar to a small part of Logstash, it's by far not that powerful. It just contains a few simple processes. You can basically have an Apache log or an Apache log entry and create or extract all the information out of this. And this is basically how you configure a pipeline. You would have a couple of processors, and the first one would basically take the Apache log line and split all of its fields out of there. So you have an own field for the HTTP method, the authentication, the URI, what have you, the referrer. And then you could convert a couple of fields to numbers, because when they're stored as numbers, some kind of aggregations only work. You still need to have a data type. We need to set a date field for this, because the date event, or the event of the date should be not when it's inserted, but when the event actually occurred in the log file. And we want to do a geo-IP lookup. So a geo-IP lookup basically takes an IP address as an input and adds some more information as an output, like an additional field which city this IP address is supposed to be from. So if you have an incoming entry like this one, it's just a single field name called message, which contains all of your data, and you're running through this pipeline. Without any other external tools, Elasticsearch will basically create a JSON document which contains a lot of different fields, like the geo-IP field here, which contains city name, country ISO code or region, the different authentication information, the HTTP verb. So you can basically start aggregating on this one. You can start alerting on this one, and you don't need any other tools in between. So a quick summary of what I was talking about is that one of the things we really take care of in Elasticsearch is ease of use. If it's hard to get up and running, it's usually also very hard to stay up and running. So we try to have a very simple experience. The only dependencies you usually have for Elasticsearch is Java. Kibana doesn't need any dependencies. It ships with Node.js. Logstash also only has Java as a dependency, but you don't need to download several tools at once. And I think this is really important. At some point in time, you always have to kind of extend the stack potentially, because you want to add your own visualizations in Kibana, for example. You have your own complex processing pipeline in Elasticsearch, or you need a specific Logstash plugin. And all of the tools I just talked about are pretty easy to extend. And this is also one of the core philosophies. It's all open source, so it should be easy to extend. And everything basically has hooks, so you can extend it. Flexibility is important. Even though I just presented like 3 different tools or 4 different tools to actually ingest data, if you have your own ingestion mechanism, it's fine. You can just use Elasticsearch, or you can just use Kibana and Elasticsearch to do visualization. And this is good. I think flexibility is important. It also makes sure that you can easily integrate it into your existing infrastructure. And yeah, that was my kind of quick presentation on the theoretical part of this. This is the awesome logging infrastructure with those tools. I compiled a couple of links which kind of back those slides up, and I will put the slides online in a second. If you get started with Elasticsearch, one last thing, read this book. You can read it for free online. You can buy it from O'Reilly if you want. It's like, I think, 700 and something pages, full of information, not only about Elasticsearch itself, but also how like distributed systems work in general, how full-text search works in general. So it's not 100% bound to Elasticsearch, but obviously this is where it makes the most sense. But it's also a lot of concepts. So if you really want to understand how search works, please take your time and read this book. I think it's very well spent time. If you want to talk, if you have questions, you probably can use Twitter or Facebook. And Mike was going to ask the questions. I will also be outside of the tech stage entrance after this talk if you have more questions. And if you want to see all of this, what I was just talking about in practice, there's a demo session by myself, which I'm going to set up a Vagrant virtual machine, and we'll walk you through all of the steps. So we will have a full setup at the end of this demo. I will also provide all the information there. So feel free to join. It's going to be hopefully a bit of interactive. And yeah, I'll be here all day. I will be here tomorrow. If you have any questions, you can ping me anytime, drop me an email, ping me on Twitter. I think we still have time for a couple of questions.
Unfortunately, Alex, no one didn't tweet anything.
That's
so I really encourage you to ask Alex questions because he'll be available also on Tech Plus stage. So thank you very much. Give a round of applause for Alex.